Hi guys, welcome to my YouTube channel LeetCode. Today we are going to discuss a binary tree problem in which we have to find the largest value in each tree row. For example, in this given binary tree level 0, we have nodes 1, so maximum value is 1. Second row, we have nodes 3, 2, maximum is 3. And in third row, we have 539, so maximum value here is 9. We will try to tackle this problem with the pre-order traversal. Right? Okay. In pre-order traversal, as we all know, we do visit first, then do go left, and then go right. Right. So let's try to tackle this question. In the starting, we are the root node here. 1. We visit that node. We are at level 0 right now. Right. So level 0. Let's create auxiliary array to store the largest found value at any level. Right? So for example, at 0th index in this array, we will store the maximum found value at the 0th level. So we are at level 1. There is no value in auxiliary array, so we'll just store 1. Now we will go to pre-order and we'll reach 3. We have reached level 1. At level 1, there is no value, so just keep 3. Again, we'll visit to left side. We'll reach 5. We are at level 2 now. At level 2, again, array doesn't have any value, so we'll just store 5. Now, after storing 5, there is no left, there is no right. So recursion will track back to 3. Now, we have already traversed left. Now, we'll go right. Again, we have reached level 2. At level 2, we'll do visit on 3. This node, 3. We see our auxiliary array here. We see that we have already stored 5, which is greater than the current value, so we will not replace it. Then move again forward, reach this node. We've already finished both left and right. We'll go back, reached 1. We've already visited left. We'll go right. We have reached this node now, 2, at level 1. Now we'll go back to our auxiliary array and we will see that at level 1, we have 3 stored, but our current value is 2, which is lesser than 3. So we will not replace it. Now moving forward, we'll reach 9. Not 9, level 2, we'll check our auxiliary array. We have stored 5. Current value is 9, so we will replace it with 9. And we will return from 9, reach 2. Again, we're visiting, we have done, we have reached root and we have visited all the nodes, so we'll come back. Now we see our auxiliary array. We have 1, 3, 9, which is the desired answer. Right. So now complexity. First, we'll discuss runtime complexity here. So since we are using pre-order, which runs in linear time, order of n, so this solution takes order of n time, which is linear, which is quite good. And space size complexity would be, since we are using only one auxiliary array, whose length will depend on number of levels. So for example, if number of levels is d, our space complexity will be O of d, which is again linear, since d will be always less than n number of nodes. Okay, so let's try to code it now. Let's create a function because we have to do a recursive solution. We'll return an integer, save find largest value. We have to take a node, our array result, and we have to track the level. Okay, we did not return anything since we are passing it to there. Now let's check if node is not equals to null. We will do visit first. That means if resulting array dot is empty, we will just push add our node value, else result empty, or if we have to see that level has not yet been reached. So result dot size is less than our level, current level. Okay. Else we already know that it has been visited. That means our auxiliary array will have some value. So let's get the current value. So int current value equals to result dot get level. Now if current value is less than our node val, then only we will replace it. Result dot set level pay will put node dot val. Right. Now we'll do left node dot left result. Now we are going one level down, so we have to increment the level. And now we have to do right visit find largest value. We'll call our function node dot right. We'll pass the result, and again we are, since we are going one level down, we have to increase the level. Right. Okay. Let's call that our recursive function result equals to new array list. Find array list. Here we'll pass root node result, and current level is 0. We'll return the result. Okay, let's try to see if it works. Okay, we are getting some out of bounds exceptions at level 1. Okay, checking again. We are at level 1. 0, 1. Result dot size here is 1, and we are at level 1 is not less than 1. Okay, we have to do this. Let's see now. Yes, so we have passed all our cases. Now let's do submit. Wow, guys. So if you see, our runtime was 0 millisecond. We have beaten 100% of users. Thank you guys for joining. Please subscribe to my YouTube channel. Thank you.